Some of them we haven't. So I thought it might be a good idea if we did some of these problems. Now, certainly, if you have a question that's bothering you, I want to do your question. But otherwise, I'm going to jump in. So you got this piece of paper, and we're going to make a box. And the questions that we're always asked are, what's the equation for the volume, what's the domain, and what is the maximum volume, and how big are the corners? So those are the questions. Sometimes they're not all asked, but those are the potential questions that can be asked. So you know what I'm talking about. Taking a piece of paper, cutting out the corners, folding up the flaps, making a box. So if the paper is 14 by 23, what would the equation of our volume be?
14 minus 2x, 1 minus 2x, times x.
Okay, perfect. What's the domain of our box
0,
going
7,
to be?
0, 7.
Because 7 is half of the smallest dimension, right? So now to get the others, we have to go to our calculator and type it in. Y equals, type in the equation. We should all be doing this because you're going to have to do it tomorrow. And I don't want any whining and gnashing of teeth. This problem didn't come from anywhere. This problem was just made up. And remember that you're ready to answer. Oh, I forgot. I have to write it in correct. A kid came off the elevator when I was walking by. Bad news.
How do you write that? How do you write that?
All right. You need to see a hill. If you don't see a hill, then you need to make your Y max bigger. And then second calc maximum. And you will get a point. If you do it right, and there's only one answer, if you do it right, your calculator is literally going to say maximum, and then it's going to give you an X and a Y, 2.821, and 409.266. Anybody else get that? The answer to the volume question is which one, X or Y? Y. So 409.266 cubic inches. The size of the corners you cut out of the paper, that is 2.821 inches. Remember that? Okay. Then I wrote down, I've got two functions, and I have to prove that they are inverses.
These are all made up problems.
Yes, these are all made up problems, so yeah, just do it on a piece of paper. I told you this yesterday. You plug them into each other, so you build the compositions. So I need to see, as your proof, that work and this work. And if they are indeed inverses, when I do all that, what's going to come out? X. All right, so let's do this one. F of g of x means plug, oops, I didn't make this g. Plug g into f, right? So that's going to be 3 1/3 x plus 2 minus 2. So distributing is going to be x plus, wait a minute. Isn't that x plus 4? So that means they are not inverses. Now, if you have to explain it, you just say I did f of g of x, and I did not get x. Now let's say you did get x. Then you would have to do this one. And this one would take this into here. So this one would be 1/3, 3x plus 2, plus 2. Now, if this one doesn't work, you're done, because they both have to equal x. But if this one does work, then you're gonna go on to the other one, and do the other one. All right, got it? What am I up here doing? Guaranteed test questions. All right, next, what do I got up here? I got this picture, and we're gonna do a couple of sketches. So this is the first one we're gonna do. This is our baseline picture. I know it's kind of small. I got a triangle that's too wide and too tall, and an upside down triangle that's too wide and one tall. All right, that's my shape. What's happening here?
Times by -2.
It goes.
Well, the
You
x's are
times
gonna
the-
be
you
multiplied
times the
by
width, you times the width.
-2, because you're dividing by a half. But that negative is going to flip you sideways. So now, my tall triangle will be over here now, and that one will be over here now. Would you agree with that? That takes care of this part.
Yeah.
Now, what does the 1/2 do?
Divide.
Divides the width by a half. So I am dividing the width by a half, which means I am timesing it by 2. So that guy right there is now going to be 4 wide, still too tall. And he is going to be also 4 wide and still 1 tall. So basically, we flipped it sideways and made it twice as wide.
Does it matter where the negative is, or does it like in the equation? Or is
Somebody
that
answer
always-
his question.
Yes.
Does it matter where the negative is? Absolutely. We already did one with the negative out front, Jake. What does the negative out front do? Tips it upside down. Okay, this is for, gave you some advice before. I'm gonna give it to you again. You gotta learn the rules. You are dead meat on this section if you don't know the rules. If you know the rules, they're easy.
I think it was overthinking.
Maybe you are. I don't know, maybe you are. Okay, then I have another one here, that one right there. I'm using the same picture, but now I'm doing, this to it. So what changes are being made in this one? What's that?
That's
All positive, so all up, I call it bottoms up.
You go down.
It's everything's up top, so I'll do that first. Big triangle stays the same. Little triangle folds up. Got it? Now, what do I have to do?
Go down one.
Down 1, that's a down 1. So again, you don't have to do this, but now my baseline's down here. So everything is gonna come down 1. And the green one is my answer.
And then if the absolute value is inside the parentheses, you're gonna mirror the
Yep,
positive.
right
side.
onto the left, yep. Positive X is onto the other side, yep.
Miss Ford, isn't the original one the triangles on the other side?
Oh, wait, was I using this one?
Yeah. Isn't the original one the smaller one? below that?
Oh, yes, I'm sorry, I was using that one, okay. All right, let me fix it again. Is that one right? Did I do that one right? Okay, so yes, Joe Garvey is right, as usual. So here's bottoms up for the original picture. This was the original, not that. So bottoms up and then down 1. So this would be the answer.
Yep.
Thank you. Yeah, always go back to the original. Always go back to the original. Okay, then what do I got? Is the log function 1-to-1? Well, you can't really answer that question unless you remember what it looks like. So remember the log function, ln(x), is asymptote here,
Yeah.
looks like this.
Yeah, it has to.
Does that pass
Yep.
vertical and
Yeah.
horizontal? Is it 1-to-1?
Yeah.
Yes. Explain your answer. It passes both the vertical and horizontal line tests. If it were a squaring function, then the answer would be no, because it doesn't pass the horizontal, right? All right. If f of 7 is -20, what is f inverse of -20?
7.
7. What do inverses do? Flip them. So -7 goes to -20, so -20 is gonna go to 7, easy. This is Chuck, plays tennis 4.5 hours a day. What percent of his day is spent playing tennis?
We do 24 minus 4.5.
4.5 divided by 24. That will be a decimal,
18.75.
and you will change it into a percent. So 18.75% of the day is spent playing tennis. Okay? All right, so I did my problems. What else do you want to do? Even if you can't find one specifically somewhere, what sort of problem do you want to do?
Go over all the graphs.
Huh?
We go over all the graphs.
What do you mean, what all the graphs are? Oh, the BFFs?
Yeah, sorry.
Okay. I gotta keep track of them. Let's see if I can even remember all of them. I'm missing some. What am I missing?
Sine and cosine.
And I got one more I'm missing.
The linear one.
I got linear.
Logarithmic.
I got logarithmic. I got integer.
Reciprocal. No, we got reciprocal.
Yeah, there's only 11 of them up there.
Square root.
Square root there.
Square root.
Thank you. Okay, so what's this one look like?
Gravel.
This one I just did.
Like a little swoop.
What's that one look like?
It's a down and then
Down.
straight out.
That one is this one, right? So it is also 1-to-1. What's this one look
Like
like?
a really form S.
That's your squiggle. That is your line. This is the one with the stair steps,
Yeah.
Yeah.
which would not be 1-to-1 because it doesn't pass the horizontal line test. Every horizontal line you draw is gonna get hit in a whole bunch of places, right?
Yeah.
This is which one?
It's a box.
It's like a little like upward.
It's your logistic function. It looks like that. This one, remember what that one looks like?
It's
One
like
corner and then
quarter.
out.
That's the two pieces.
The reciprocal.
The reciprocal of the two pieces. sine and cosine, those are
That'll
the
be
It has a
Yeah.
balance.
waves. And because they are waves, they are not one-to-one,
One's to the
because
origin.
they're not gonna pass the horizontal line test. And what's this one? The swoosh? I guess, yeah, like that,
Yeah.
okay. All right, what else? Come on, guys, let's test this tomorrow. So the problems say something like, the height of a cylinder, I keep spelling it wrong, cylinder is,
So 11.
twice the diameter.
So that was 11.
Right volume in terms of radius. Okay, so what do we start with? What's our, this is where I begin.
Volume equals
Volume equals, and what does volume equal?
pi r
Pi
squared
r
I.
squared h. And that's a good formula, but it's only supposed to have r's. So I'm gonna go back to this right here, and it says height is twice the diameter, which means height is 2 times 2 r's, because diameter is 2 r's. So height is 4 r's, so pi r squared 4 r's, 4 pi r cubed.
You have to do that last step.
Do you have to go find your ball when you lose it? Yes. All right, well, I guess if it's never right. All right, what else? What else? Well, to get the match I went to, they said he was the best in the state.
Oh.
I don't know if it's still true or not, but that's what it says. Now, we're gonna see if he's best tomorrow.
Ooh.
All right, who else? Another question?
Good joke.
Let's see.
What else? Come on now, we have a test tomorrow.
Let me see.
Do we know exactly what's on the test now? Are we clear on that?
Oh, can we do number 4 on extra practice 1517?
What does the question say?
It's what equation that represents this curve and it has the type of graph on it.
Oh, okay, so that's extra practice. Extra, I thought he said extra practice.
Extra practice 15 and 17.
Extra practice 15 to 17. Oh, I found it. It's actually the last page, or no, next to last page of the packet. Extra practice 15 to 17, and then look at problem number 4. We did some of these, we did at least one of these yesterday. Look at problem number 4. Okay? So look, the original picture is drawn. So this is the second to last page of the packet, problem number 4. So before I start writing an equation, let's make a list of everything that has changed in going from the original problem to the picture in number 4. So what are some of the things that you think have changed?
Sideways flip, up 2.
All right, wait. Calm down.
Dang, Joe.
We got a sideways flip. Would everyone agree with that? That the picture has gone this way? All right, what else, Joe?
Up 2.
Up 2. He says we've lifted it up 2. And really, is that it?
Yeah.
Okay. So now I have to write my equation. And remember, your equation is going to be some version of that. You're just going to put in the numbers or signs, negatives or whatever, that make this happen. So what do you think?
+2 on the outside.
Plus 2 on the outside,
Negative.
because we know that
Negative X.
lifts you up 2. And negative right here, because that flips you sideways. Agreed? So that's the backwards of the graphic. So again, Jake, S, if you know your rules, you're gonna be fine,
Mhm.
because you're just now going backwards. How do I make that happen? How do I make that happen? Alright, good question, good question.
It's the one where you only, the mirror, you only do the right side.
Which, like, notation is the one where we mirror the right side onto the left?
That's when it's,
Absolute value of just X. That mirrors. You draw the right side, draw it over on the left. Alright, what else? Do we need another mixture problem? Do we need another inverse problem? Do we need another parametric problem? What do we need another one of? You guys are so lazy, I can't even believe it.
So, parametric.
Alright, so you've got a couple equations, y equals 2t minus 4 and y equals 3t. And our job is to write one equation in terms of x and y, okay? So we want one, got two, want one in terms of x and y. So what would that look like? What would I do?
Try to get T by on the top.
Probably I'd go down here and say t equals y over 3. And then take this and put it here. So y equals 2, y over 3 minus 4. So 2y over 3 minus 4. Done. Right? Done. What about,
and would it be x equals 2y over 3 plus 4? Yeah, it would be x.
oh, it's x equals, oh my gosh, thank you so much, yes, x equals. I was plugging into this equation right here. No,
Yeah, because there has to be an x and a y.
yeah, there does, but why, what happened?
You didn't put
Oh,
y.
I didn't put x equals here.
Do X and Y have to be on the same side? Or is that,
No,
is that Cartesian?
yeah, standard form,
Do we have to have that?
no. We just have to have one equation with x and y. Yeah, I wrote that. This is the way I should have written it. Yeah, now it's okay. Alright. Alright, let's find the inverse. Now, the other, you just
Y,
quickly
x equals
find the
2y
inverse.
over 3y plus 1.
So we start by switching our variables, remembering that f of x is y.
Multiply on the other side.
Bring this over to the other side.
Then you
Distribute, please distribute.
then you pull out.
No, don't pull anything out. I need to put the y's on the same side. It's the y's I factor out. So I have to have them on the same side. So these guys are going to switch. So 3xy minus 2y equals negative x.
Now you pull out.
Now I pull out. And then divide. By that parenthesis. Now, what's the domain? This is my inverse. So here's my inverse answer. And then the next question will say, okay, what's the domain of that inverse?
3 to 2 over 3 and 2 over 3.
X cannot be 2/3. Would you agree with me? X can't be 2/3. So think of a number line. I'm 2/3. I can be everything less than that or more than that. So that's negative infinity to 2/3 or 2/3 to infinity. Everything except that 2/3.
Now we're good. We'll only, like, for all these, we'll pretty much only do domain, right?
Yes. What else? I'm losing track of my thoughts here. We did all that. Okay, on this extra practice sheet, it says my allowance is $250 a week, and I spend 49, boy, you can tell how old this sheet is, spend 49 cents on a stamp. So what percent of my allowance is spent on a stamp? 0.49 divided by 2.5?
19.6%.
So 19.6%. Now you can barely buy a stamp for $250. Number 8, let's set it up. I'm looking on that same sheet. It's a mixture problem. How many ounces of 73%? Let's get it set up. Even if we don't have time to finish it, let's get it set up. How many ounces of 73% needs to be mixed with 20 ounces of 34% to get a 60% solution? This is gonna be X plus 20. And then I'm going to distribute, and, we think around and come up with my answer, right? Okay, so remember tomorrow, or the last period of the day,
Are we taking the test or not?
yes, we're taking the test, and then you leave when you're done. And if you have to leave at 12:10, then you're only gonna take one page. And then you have to do the second page at another time. Okay?
Yours the longest with you back. Can we be there for like an hour, 15 minutes?
What are the right here?
It should.
So but I really don't
What in
think
your
it's
lap?
gonna
Nah, I don't think so. How long are they?
30.
30 minutes. The next.
You go to the West Virginia. Where you were sitting today, I found an appointment card.